Now we need to take the dimension for the different parts. So again, to start once again with the main body, you can see that we have multiple dimensions here. This one is flat. This one is actually inclined. We don't have any fillet on the side, and this will make it much easier to be measured. So first again, to check what will be the distance from here to here, we have some 10 millimeter fillets here. Actually it's going to be easy to be sketched by using the SolidWorks. Now the dimension we have here is going to be mainly 80 millimeter for the width. That's without the fillet, 80 millimeters. Then and this will make it, of course, 90 millimeters with the fillet. The maximum width is going to be 135, and the maximum distance here is going to be 132. Okay, so we're looking at 135, and we're looking at 130 millimeters, 132 millimeters for the width. 135 and 132. What we need to measure now, actually by knowing this one is going to be 90 and this one 135 and this one 130, you can sketch the hexagonal shape accordingly. Now let's look about the length of these straight lines. We're looking at this one is 32 and this one is 32. Actually both lengths are identical, so this flat side and that flat side are both 32 millimeters. The diameter of this one should be equal to the diameter of the gear, which is looking at 57 millimeters. Diameter here is 57 millimeters. Now look for the maximum distance from the sides, because this will help me to sketch the part. I'm looking at 105 millimeters. Okay, 105 millimeters from here to here. Now check the thickness of that wall. I'm looking at 70 millimeters. Thickness of the wall here is 60 millimeters. Now let's do some basic measurement for the heights. I'll find the dowel here. Okay, so this height is going to be equal to 93. Okay, and for this part we're looking at we're looking at 59. Okay, so this one is 59 from here to here. We can estimate what will be this one. It's up to you. I think it's going to be something around 59. We're looking at approximately 35 millimeters. I mean, for this rounded shape. The height of that part can be found by direct measurement to be equal to 41 millimeter. Okay, and of course this will give you the difference between both doubles here. The height of this part definitely is going to be the same as the height of the other one. We're looking at the diameters here. That's what we're going to measure. The maximum distance from here to here, I'm not sure if you can do it. Yeah. So this maximum distance is going to be equal to 104 millimeters, 144 millimeters. Maximum distance from here to here. And you can see actually that this side is going to be the same as this one is going to go a little bit higher, and I think that this in here it can be measured by subtracting the 135 with what we just measured here, which is 144, and this will give me that this extra distance is going to be equal to 9 millimeters. So this gap between them is 9 millimeters. Now we're looking at the diameters we have for the external of the port. Okay, so we're looking at 70 millimeter for the larger one, and we are going to have 56 millimeters for the smaller one. We're going to check the diameters here. I'm going to check this small height between these two surfaces. So first I'm going to check that, and this will be equal to 17 millimeter. It's up to you to add this support in the middle. The diameter we're going to have here with inside the thread is going to be equal to 32 millimeters. For the outlet port is 45 millimeters. Okay, so of course you know the diameter of the outside, and you can check what will be the thickness of the wall we have here. The depth of the thread we have for both, for the outlet port, for the inlet port is going to be equal to 22 millimeters. That's the depth we have inside, and the depth for this one is same thing, 22 millimeters. Okay, so the depth we have here is 22 millimeters. I don't have any information about the mass. I don't think it's going to be very important for us, but no, I think it's going to be quite important. So I'm going to try to find the mass for these blocks and share it with you. Now we talk about this part. Once again, we said it's going to be done by the casting, and then we're going to have some operation to finalize it. Let's check. Of course, the dimension is going to be the same, so no need to be done. Let's talk about the slot dimension. Okay, so the slot dimension, you know that this usually the elliptical shape is going to have the A and the B. The A is going to be the maximum diameter, the B is going to be the minimum diameter. So here I'm looking for the smaller one is going to have 79 millimeter diameter for the B, and for the A is going to be 117, 79 and 117. That's for the internal one. The thickness we have for this slot is 4 millimeters. So we have 114, we have 117, we have 79 for the internal wall, and then we're going to have 4 millimeter gap between them, so you can do it by the offset. The depth we have for this slot cut is going to be equal to 3 millimeters. So the depth of the slot is 3 millimeters. The slot, of course, is going to be cut on the milling machine. You're going to have a small diameter cutting tool, and it's going to be moving in elliptical shape to generate the slot. Now we check the diameters of the and the wall thickness for the bushes here, and we are going to have the internal diameter for the bushes is 30. The external diameter for the bushes, which is the diameter for the bush housing, is going to be 35. So once again, we're going to 2.5 wall thickness for the bushes. Now the depth here actually is going to be, I think that the length of the bushes in that case, okay, we're looking at 44 millimeter the total depth, and the I'm going to do it with a ruler because actually I put something inside to hold it, and we're looking at 40 millimeters the length of the bushes we have inside. The dowel hole in this model is going to be different from the other one. Okay, so the dowel hole depth is going to be equal to 30 millimeter in depth. The diameter here is going to be 12 millimeters. 12 millimeters. The dowel dimensions are 12 millimeters exactly. So I expect that it's going to be 12 millimeter plus 0.01 millimeter or 0.05 millimeter. So we can force it by the press force to sit inside. The diameter of the holes here is going to be 12.5 millimeters. So I think that we're using the MA12 thread. Sorry. What do you call it? The MA12 bolts to bolts to fix the two parts together. Now let's talk about the thicknesses we have here. And the thickness here is 20 millimeter for this part. We're looking at 18 millimeter, 17 millimeter for this part. I think this will be identical with the previous one. Definitely, I think that this was going to be 80 by 80 as we have earlier. No, this one is 84 by 84 by 84. The diameter of the circle we have inside here. The external diameter is 62. The internal diameter is going to be 52, and for the diameter, the outside diameter of the housing for the seal, 45 millimeters. So 45 millimeter for the housing for the seal, 52 and 62 millimeters. The height, four millimeters. Okay, so that's basically the dimensions. We still have the total height here, and this can be done by many ways. So I'm going to use gap between both is 50 millimeters. So the gap between both is going to be 20 millimeters. So we're talking about 20 millimeters, 17 millimeters, and the gap between them is going to be 50 millimeters, and this will give you the total height of the main body. Now we go to the shafts. Now we have difference between the shafts. I expect that the length is going to be quite different here. Okay, but the good thing with this shaft is that both heights are going to be identical. So let's check the main shaft first. The maximum diameter we have for this shaft is going to be at the gear level is equal to 57 millimeters. The second diameter here is 30 millimeters. The dowel, the minimum diameter we have here is going to be 22 millimeters for the supply, and I expect that this diameter is going to be the same, of 30 millimeters. 57, 30, 22, 30. Now we're talking about the length. So the length, once again, I'm going to take this length by using the vernier, which is 64 millimeters. We're looking at 46 millimeters. We're looking at 58 millimeters. We're looking at 27 millimeters. And this one is 90 millimeters. Okay, so again, we're looking at 57, 90, and 27. For this side is 47 millimeters. Okay. 47, 47, and of course it's going to be the 64 millimeters. Okay, that's what we have for the shafts. For this plate, the maximum distance we can have uh, 103 millimeters. The width is 57. Small distance here, 34. The diameters, remember that the diameter of the shaft was 30, 31. Another way to do that, again, I can put that on the milling machine and do the machine for it. But the only problem we're going to have for that is how to hold it on the milling machine table, and I will leave this one for your research. But this can be done on the milling machine. Now for the assembly process, it's heavy. Okay, so you need to carry it from the box, put it on the table. It's quite heavy. Take a look on it this way. Start to put the parts in. Of course, I need to draw one of those inside, and then I get to put the gear number 1, followed by the gear number 2. Check they are moving freely. That's good. Put the thruster plate. Thruster plate, the flat side is going to be attached to the gears. The groove side is going to be facing the top. Okay, so we'll put it in. Now this is one of the problems. They're going to have very high tolerances for the cavity. So I'm not sure if I'm going to put them in. It's going to be hard to take them out. And then the highest level to the highest gear, the lower level to the lower gear. The dowels is going to tell me how to fix it. Now, that's one of the problems. I have one of the dowels here. The other dowel is going to be on top of it. That's mean I put them in the wrong direction. So that's something you have to remember while you're doing these things. Okay, so now if I get to change the direction, the dowel is going to be on the empty dowel hole and vice versa. And then it can sit and it will actually fine. Now we reduce the error of the assembly simply by having the two sides of the shafts are going to be identical. We're always going to have it in the correct direction. Now we're going to talk later about the testing procedure for the pump.